So why transform your variable? Well, one of the assumptions of parametric tests is the assumption that your dependent variable is approximately normally distributed for each and every level of your independent variable. If you violate this assumption, you will need to transform your non-normally distributed data to normally distributed data. Another reason is that you may have a variable with extreme outliers. When you transform, the values shift in that you may not have either extreme outliers or any outliers at all. Thus, transformations are one of the critical parts in data management, and there are 6 different types of transformations. There are 3 transformations to use if you have positively skewed data. Positively skewed data is when your data is skewed to the left, usually lower numbers on the x-axis. And then there's 3 transformations in case you have negatively skewed data, which usually indicates higher values on the x-axis. So you have 3 for positively skewed data and 3 for negatively skewed data. The 3 start from skewness at the moderate level, the strong level, and extremely skewed level. So if your data is skewed in either way, you start off with the moderate transformation, which uses a square root function. If your data is strongly skewed, either positively or negatively, then use a log 10 function to correct your data. And in the case that you have some really skewed data, either positively or negatively, you will divide your dependent variable or your variable that you're looking at by 1. Rather, 1 divided by your dependent variable. I will show you how to perform each of the 6 transformations using my data. Okay, we're going to transform a moderately positively skewed data. And the way we do that is we go to transform, compute variable window pops up. We'll name our new variable, because we create a new variable when we transform our data, square root underscore name of my dependent variable lies. Go to the functions group list, pick arithmetic, go down to square root, pull it up, hit this arrow, it takes the square root function to the numeric expression box. See, it has a question mark. Go to the lies on the left hand side, my dependent variable, put it there, and it moves from this box to the numeric expression box, and push OK. Alright, in the case that you have a moderately negatively skewed dependent variable, you still have to conduct the square root function to correct for it. The difference is you have to identify the largest value of your dependent variable. And the easiest way to do that is to go to your dependent variable, right click, and hit sort descending. The highest value for my dependent variable is 17. So as we did with this square root for the moderately positively skewed data or dependent variable, we go to transform, compute variable, we'll do square root lies underscore and EG for negative. So we have the square root function from the last command, so let's just get rid of that. So we can go through the function group for arithmetic, square root again, bring it up. We have our highest value, which is 17, so we go into the parentheses, type in 17, and then we add 1 to that. And then we're going to subtract our dependent variable. Okay, as you can see, our new dependent variable has been calculated. So now we have square root for moderately positively skewed dependent variable, moderately negatively skewed dependent variable. Okay, sometimes your data is extremely skewed to the left, or in other words, strongly skewed to the left. Then you have to use a different correction than the square root function. And what we do there is we go to transform again, compute variable. Instead of square root, we're going to use a log 10 function to correct. I changed my target variable name. Let's delete this. We're going to go to arithmetic again. This time we choose log 10. We bring it up. Move our dependent variable over. Hit OK. Now we have our new variable calculated. And it is also equally possible to have strongly negatively skewed dependent variable. So, similar to how we worked with the square root for negatively skewed dependent variable, we're going to do the same thing. Go to transform, compute variable. I'm going to add negative behind it just to know that this is a strongly negatively skewed dependent variable. So what we're going to do here is we need to get the same information that we had last time, which is the largest value. As we know from the last square root that we did for a negatively skewed dependent variable, we know that 17 is our largest number. We're going to add 1 to it. Okay, then we're going to minus our dependent variable. Push OK. And here is our new transformed dependent variable using a log 10 function. Okay. There are also cases where you may have an extremely positively skewed dependent variable, in which case we have to use a completely different function than the square root or log 10 correction. So we go to the same place where we've been going to, which is the transform compute variable, and this time I'm just going to name this extreme to know that this is extreme transformation I'm using for this dependent variable. And what we do here is we take 1 divided by our dependent variable. Push OK, and we calculate the new dependent variable that has been transformed for extremely positive skewed values. And the last transformation we're going to work with today is going to be the counterpart to the last transformation, which is going to be a transformation for extremely negatively skewed variable. In this example, my dependent variable. So what we do is we go back to our transform button, compute variable, extreme lens, I'm going to indicate negative, so I know. And we're going to keep the one divided portion for this. And then we're going to enter, like the previous functions for negatively skewed data, our highest value plus 1. We want that to be calculated. We're going to end another parentheses because we're going to subtract this by our dependent variable. Close parentheses. Okay, now we have our last transformation, which is an extreme transformation in the case that you have an extremely negatively skewed variable. In my case, it's my dependent variable that has been transformed because the values were so skewed to the right.